This thing's probably on, huh? Howdy, folks. My name's Eric. I'm with Brent Ozar Unlimited, and I'm going to talk to you today about a subject that is rather near and dear to my heart. Now, usually I when I write blog posts, I just write them. Uh, I started writing this one, and I got really lazy. Because there was a lot of screen caps involved and a lot of words, and I didn't want to do that today. It's Saturday, and all I wanted to do was just tell you about something kind of quickly. Um, so what I want to talk to you about is a concept that's near and dear to my heart because it comes up a lot. Just doing like kind of like everyday query tuning, working with clients, looking at questions and answers on TBA.Stack Exchange, and that thing is SARGability. And SARGability comes down to when you write queries and you want them to be fast, your goal should be to write the simplest query you can. Now, there are all sorts of things in SQL Server and T-SQL that make writing queries easier for you that don't necessarily make your queries easier on the optimizer. Some of the stuff that comes to mind when we think about things that aren't sargable and things that make the optimizer's job difficult is when you have joins and where clauses and you do stuff like wrap columns and functions, right? So you have like, say, some function like replace, substring, car index, pad index, is null, coalesce, one of those, year, month, day. You have one of those on a column and you want to compare that to something. So when you wrap a column in a function and you compare it to something, SQL Server is kind of going to make a bad guess, maybe do some extra work to try to figure out exactly what it is you're looking for. If you do the same thing and concatenate two columns together, so column plus column equals another column equals a predicate, variable, something like that. If you start appending values to columns, like column plus value or value plus column, and evaluating that, one that's kind of tricky and always sneaks up on people is when you do like the column equals predicate, column equals parameter or parameter is null trick. That is also not sargable. Sort of like the needless to say variety is like when you have a like predicate with a leading wildcard string, and SQL has to go and like search through entire strings to do stuff. Or if you want to compare a column to a case expression, so you column equals case when yada yada yada, that is also not sargable. When you do that stuff, your queries can end up with all sorts of bad things happening to them, happening to your hardware, your query plans, your cardinality estimates, all sorts of stuff. Yeah, increased CPU time. You could end up with index scans. You're reading like the entire index instead of just seeking to like a little range of values that you need. You can end up with implicit conversion, especially if you're comparing like the column function equals something, and the result of that function, like the output of that function, doesn't match the data type of something else. Then you end up with implicit conversion. That's like a whole other nightmare. You can end up with really poor cardinality estimates because SQL Server like knows what the column looks like on its own, but then you apply this function to it, or you like put two columns together, or say like column plus a value. SQL Server has no idea how many rows are going to result from that. It just makes these sort of magic guesses, which are often really, really wrong. Those wrong guesses can lead to all sorts of things like inappropriate plan choices, right? Like hash joins instead of nested loops joins or merge joins, or like, just way different kinds of aggregations, like all sorts of bad stuff going on in your plans when you start doing these non-sargable things. Those non-targetable things can typically make your queries run for a lot longer than you'd like, or just longer than you'd like, or use more resources than you want, which reduces concurrency, and the whole thing just kind of stinks, and it all comes back to just write the simple query. So, what we're going to talk about today is when sargability matters the most. Now, obviously it matters sometimes if I'm here talking about it, so we're going to talk about when it really does matter the most. So all the examples that we're going to go through today are courtesy of the Stack Overflow database. If you want to download your very own copy of it and follow along, you can go to brentozar.com/go/query stack. And we're going to be working with the comments table today. The comments table is fairly big, which we'll look at in a minute. And there's lots of interesting stuff in it. So let's go look at it. So how big is that comments table? If we go hit F5 here real quick, we can see that comments table, and I'm going to apologize in advance. I'm using Zoom It on a VM, and sometimes it's a little touch and go, maybe a little hazardous. Sometimes it does this like crazy like epilepsy dance where it zooms in and out and does awful things. But let's hope we avoid that today. So the comments table has about 68.3 million rows in it. So it's not the biggest table in the world, but it's a pretty good sized table. And you can, this is like the size of the table, you can start to see the kind of ill effects of non-sargable predicates. On smaller copies of the database, they're much less pronounced. So it really does take like a fair chunk of data to start seeing the ill effects of non-sargable queries. So let's go take a look at some stuff. These are two queries. Query 1 has a sargable predicate on user ID, so we're looking for where user ID is not null. And query 2 has a much less sargable predicate, and this is where is null user ID negative 2.1 billion is greater than 0. If I run these two queries, now I don't have a good index to support these queries. If I run these two queries, I'm going to end up with queries that do just about the same thing. They're both going to scan the clustered index of the comments table, right? They both do the same thing there because I don't have a good other index to use. But only one of them, in the eyes of the optimizer, is worthy of getting an index created to help it out. That index is on the sargable predicate. So on this one where I said where user ID is not null, SQL Server says, hey, you know what? I was thinking about it. I was running this query, and I sort of think that an index would help. I think we should get indexed here. And it's right. An index really would help this query. I'm not saying that the missing index requests are always right. They are profoundly wrong sometimes. But in this case, it's not a bad guess. If I flip over to the Messages tab, because I don't have a good index to use, I end up doing just about the same amount of work in both of these. All right, about 2.8 something. Oh, wrong comma there. A little bit off. So in the realm of like 2.9-ish million logical reads, because I have to scan the entire clustered index in both of these. I don't have a better way to do that. The CPU time is just about the same too. 1600 milliseconds, about 1800 milliseconds. The elapsed time, and then the CPU time is only off by about a second. So nothing changed with these, and I'm like gonna go run and tell the boss about like I made this query sargable, and look, I saved 1,000 milliseconds of CPU time. No one's getting a raise from that. No one's getting a better review from that. Your boss is going to throw a coffee cup at you. Just like, that's it. If I went and did that to Brent, he would probably mute me on Slack for a week. So the index that SQL Server wanted on whatever is on the table but disabled. So I'm going to rebuild that index so we have it for the next time this runs. And the next time that we run these, let's go see if these queries will actually use that index or not. Let's go see what happens. So again, we have these fairly non-selective predicates. Right? Both of these queries returned a big chunk of that table. If we go and run these queries with non-selective predicates again, and let you know what I mean by non-selective, is that if you recall back, we have about 68.3 million records in the table. These are returning 67.5 each. That's most of the table. That's not like a very selective, like small number of rows from the table. That's the whole thing minus just plus or minus a million rows. If we go look at the Messages tab with our new index, they're both still doing round about the same amount of work. 118,000 reads, 119,000 reads here. They're both doing a pretty good chunk of CPU time, right? Still, it's a little bit different. It's a little bit like the difference is a little bit more spread out. But if I ran this 5 or 10 times, the sargable query would never be worse, but they would be closer and less close on other iterations. I've run through this a lot. They're not always off by 500 milliseconds. Not that 500 milliseconds is that big a deal anyway. The execution plan does get a little bit more interesting, though. Now for our sargable query, where we don't have a function wrapped around the column, we are able to seek into the index. Which sounds good, but we still have to seek and read 67 million rows. That's not better. That's not much of a seek. So we can seek, but is it really that much different from a scan? The second query scans that non-clustered index, so it still uses the index, but like I just don't see like the real benefit here. If you go and we zoom in a little bit on the tooltips, well, you can see that we did indeed read just 67.5 million rows, but who cares if we seeked 267.5 million rows out of 68.3 million? That's not a big deal. That's not like something I say, yay, seeks win. The scan did almost the same thing. It just read about a million more rows. Again, who cares? That's not a query tuning win. With more sargable predicates, with more selective predicates, sargability does start to matter more. So I'm going to run these. I'm going to run these slightly differently. Before we were looking for where user ID is not null, and where is null user ID is greater than 0. Now we're going to be looking for where user ID is null, and where is null user ID negative 2 billion is less than 0. So this is where some cracks will start to show. Now, you notice that both of those results returned pretty quickly. Let's go look at why. If we flip over to the Messages tab, our sargable query, well, it only does 1,300 reads. Our non-sargable query still does the same amount of, still does that 119,000 reads. It still has to scan that entire non-clustered index and read every page and flip user ID with the is null and figure out what that is. But where things get interesting is with the CPU and elapsed time. Now, with the sargable query, we do 62 milliseconds of CPU time. We do 1 scan of the table. With the non-sargable query, we do about 6 seconds of CPU time over 13 scans of the table. This is because the non-sargable query went parallel. I'll show you that in a second, but before we flip over to that screen, the sargable query has about 55 seconds of elapsed time. The non-sargable query has about 515. The only thing that keeps this non-sargable query even remotely competitive in how long it took overall is that it did go parallel. That the sargable query on the selective predicate didn't need to go parallel. That's this plan up here. There's no little parallelism operators, right? We don't have our little racing stripes like we do on the non-sargable query. So the only thing that kept that non-sargable query even remotely competitive was that it had to use a ton more resources. It went to max stop 12. It went and used 12 cores to process that query. That's not a good use of resources. If we write sargable queries for our selective predicates and we can seek to just the rows we need, we don't have to do all this extra work and sit there looking at our queries. Why is it all this CX packet? I don't understand. What did I do? The index seek just goes right to the 761 or so thousand rows that we need to get. We are able to seek directly to a small chunk of data where an index seek is helpful. The index scan on the non-sargable query, well, we still have to read all, little zoom it malfunction. We have to read all 68.3 million rows just to get to the 761,000 we care about. This is when sargability starts to matter a whole lot more. So, what we know so far is that the sargable query can seek, but now it can really do a whole lot less work. When that non-sargable query does the scan, it goes parallel and uses a whole bunch of extra resources. If we limit that non-sargable query to only being able to use max stop 1, if we say no, you can only use 1 core here rather than go parallel, you'll start to see why things are a little bit wonky. So let's go look at the Messages tab if this thing ever finishes. And this one took about 3.5 seconds. So using a single core, using 3.7 milliseconds, 3,700 milliseconds of CPU time, which is about 3.7 seconds, it takes us about the same to produce the query results. We still have to read all that, but this time our query does not go parallel. We use a serial query where we have to scan all those rows, and that is in fact a slowpoke. So when we control for parallelism, we can start to see why the sargable query is much more efficient. We can read like a very small number of rows very quickly, versus the non-sargable version either using max stop 1 and taking 3.5 seconds, or just barely staying competitive by using 12 cores and going parallel. So what we know right now is that sargability matters when predicates are selective. Right, and where we're dealing with the leading key column of an index. So when we have a leading key column in the index that really helps our where clause, and it's the leading key column of the index, writing sargable predicates is helpful. Right, so we can seek right to the small number of rows that we're interested in. With different predicates and different indexes, things start to change a little bit. Now we're going to use a slightly different index here. We have one on score in the comments table and then user ID in the comments table. When we look at how many comments in the table have different scores, I'm just going to grab this. I'm just going to select the top 10 most populous comments from the table. So I have this select top 10 score count from comments grouped by score, ordered by the number of records that each one returns descending. 0 is most of the table. It's about 58 million out of the 68 point something million comments have a score of 0. 1 has a good about 7 million, 2 has about 1.8 million, and then on down the line. So 0 is most of the table. So if I run these two queries, which are not selective, right? That score is not selective. If I'm looking for a score equals 0, that's still most of the table. Well, SARGability can still matter here. And with the SARGable predicate on user ID, I only have to read about 1,400 rows. With the non-SARGable query, well, I'm still reading 131,000. Whew. And again, the same sort of interesting thing happens where this query is serial and quick, right? CPU time 47 elapsed time. This one is definitely parallel, right? We're doing that 13 scan count, right? Maxed up 12, use 12 threads to process the query. And this is, again, barely hanging on to competitive with 5 seconds of CPU time and about half a second of elapsed time. If we go to the query plans, we kind of have the same story as the last time. We have an index seek to just the rows that we need. But what's really cool is how many seek predicates we have down here. We can see that we have 2 seek predicates. We have one on the score column where we found 0, and then we have one on the user ID column where we found the nulls. So we were able to, seek into the index and evaluate both of those predicates pretty easily. With the non-SARGable one, well, we're left with this kind of ugly residual predicate. Look at that. So we only have the one seek down here. So we weren't able to support the double seek into the index. We ended up having to seek to the rows that we want for score equals 0, and then run that function to figure out which ones will evaluate to true based on that is null. So the SARGable query does a lot less work. The non-SARGable query needs to go parallel to stay competitive. If we do the same thing that we did before and we control for parallelism, it's going to be kind of a bummer. This is going to take that same almost 3.5 seconds to do the same work, right? So we control for parallelism. The non-SARGable query really does take a nosedive as far as efficiency goes. Again, when it uses way more resources than it needs to, it can stay like ballpark competitive, but as soon as we remove those resources, it craps the bed. It's really in a bad place, still having to read the 130,000 rows, still doing about 3 seconds worth of work. So not good there. Not a good showing for the non-SARGable queries when we don't have very selective predicates. When we have really selective predicates, though, like now we're going to use the post ID column. And the interesting thing is that the questions with the most posts, so post ID is what the question that the comment is related to. If we look at this, the question with the most, the question or answer, it could be an answer too, because in the post table it has questions and answers. If we look at which post in the post table has the most comments associated with it, it says 38892391, which has 157 comments on it. That's not a lot of rows compared to the 68 million rows that are in the comments table. Right? So there's 68 million rows in the comments table. This one question, which has the most comments, still only has 157. If I run these two queries, where I'm looking for that post with 157 comments, and I have the same sort of predicates over here, where user ID is null, and that's SARGable, or where is null user ID is less than 2.1 billion, which is, again, not SARGable, this doesn't matter much at all. These both do very little work. The difference in logical reads is, again, nothing I'm going to barge into the boss's office about, and neither of them use a darn thing for CPU or elapsed time. But that's only because that leading predicate that we did the seek with was really, really selective, only 157 rows. So again, sort of the same story as last time, where with the SARGable predicates, we have 2 seeks, into the index. With the non-sargable predicate, we have a seek for the sargable predicate, which is where post ID equals 388 whatever, and then the non-sargable residual predicate to evaluate the function over on the user ID column. So with really selective predicates, the sargability of residual predicates can matter less. With non-selective predicates, the sargability of residual predicates can matter a lot more. So what did we learn? When sargability matters most is when you have when you're dealing with leading index key columns. When we had the index on user ID and we had the sargable versus non-sargable predicates on user ID, the sargable predicates on user ID when we had selected predicates really did make a difference. When sargability doesn't matter much, well, if you're not dealing with the leading key column of an index, when you'd have to kind of scan it anyway, and when you have really selected predicates on leading index key columns. Anyway, I've been talking for a while now. See, this is why I didn't want to write all this stuff. This would have taken forever. It's a 20-minute video. Do you have any idea how long it takes to write 20 minutes worth of words? Oh, it's awful. The screen caps and the circling and the arrows and the funny, trying to come up with something funny to say. And boy, oh boy. Hopefully you will never know that pain. Anyway, I hope you learned something. I hope you enjoyed yourself. And maybe next time I will just write this stuff instead. Have a nice weekend.